Oh, hi there. Thanks for showing up for your learning. Here we are going to stretch some functions. Now, you have not seen cubics, all right? We've not worked on cubics, and we didn't even list them as one of our parent functions. We're kind of saving the cubic surprise for grade 12, if you know what I mean. But you can still transform them, okay? Because the rules for transformations apply to all functions. So if we have y is equal to 3x cubed, they're showing you the parent function there, which is just x cubed. And you're going to say, well, y is equal to some a multiplied by x cubed. That is an a transformation that's multiplying the outputs. So we're just going to stretch everything up by 3. I see that this point 8 there, that's at 2, 8. That's too high to be stretched by 3. So I'm going to take the 1, stretch it up to 3, and I'm done. Perfect. There, stretched by 3. Submit the answer. Yes. Yay. Let's try another one. 2 absolute value of x. Okay, take one of those points, stretch it up by factor 2. You could take the point at 1 and stretch it up to 2. You could take the 2 and stretch it up to 4. You could take the 3 and stretch it up to 6, or whatever. Okay, there, done. Okay, that's a stretch vertically by factor 2. Submit. Yes. Okay, vertical dilation of 2. Oh, they like to use the word dilation. All right, I say stretch. All right, and that's why you like me. Oh, a horizontal squish. A vertical squish by 1/3. Notice that's outside the machinery of the function, so it is squishing it down by 1/3. Notice I chose the point that was at 3, because that's the easiest to bullseye onto a point. There, that's the square root function squished by 1/3. Submit. Yes. Yes, no problem. A 4 cube root of x. Well, that's going to stretch everything up by factor 4. So this point is at 8, 2. Stretch the y value by factor 4 up to 8 to the point 8, 8. There we go. That's a beautiful looking function, isn't it? Oh, that looks really cute. Cool. Anyway, cube root, the fourth cube root of x. That's a nice one. I'm going to have to build some Desmos art around that. Let's keep going. All right. 1/8 x cubed. Well, fortunately, this point up here is already at an 8, so it just comes down to 1. Right? Its x value doesn't change, just the y value. All right, so I'm seeing a lot of y value transformations in this level. Let's go to another one. Stretch compression functions level 2. Oh, this one. They're multiplying the x values by a half. All right. This one is a k transformation. Okay. It's not outside there. It's inside the function. It's y equals the cube root of 1/2 x. It's multiplying the inputs directly. So its effect will be to divide all the x values. A transformation point would look like this. We would take x and we would divide it by 1/2. And then our y values would remain unchanged. So in this case, we're going to have 2x there. It's going to be multiplying by 2x, because dividing by a half is the same thing as multiplying by 2. Okay, so let's do that. So I'm going to take this and I'm going to drag it out by 2. There. And it's going to say, well, congratulations, you did a great job. That's what it's going to say. It's going to say, great job. It says, great job with that great big green check mark, and I feel good. Okay, y is equal to 4x. Again, these things are going to be squeezed to the y-axis by factor 4. Cool, eh? Cool. Yeah, so that is our new function. And again, because it's a k transformation, so it works a little differently than you might expect. Here, this is y is equal to 4 multiplied by x, but we want the absolute value of that. So that means our transformation point is x over 4, y. So you just take your x values and squeeze them towards the y-axis by a factor of 4, by that factor. Okay, k values divide x's, a values multiply y's. Submit. Yes. Yay. Horizontal dilation by a factor of 1/4. Okay. Take the reciprocal for f of k multiplied by x. Okay, so that's what we're doing. We multiply the x coordinates by a factor of 1/4. Yeah, or you could say divide them by 4 is the same exact thing. This one is by 3. So let's take a 9/3 and bring it to 3/3. Okay, same idea. Submit answer, yes. We new one. 3x squared. So take this one at 3, x is 3, and bring it over to 9. Like that. So this is how we handle k transformations. And so you've seen lots of A transformations, but I didn't show any with the point transformation. Let's do this one. 2x squared. This is the parent function for 2 to the x. Sorry, 2 to the x, not 2x squared, 2 to the x. And we're transforming it by a quarter. So, and that quarter is an A transformation. It's multiplying the whole function. It's not just multiplying the x. If it was a K transformation, it'd be up there inside the exponent. So, a point xy will map under this transformation to the point x is unchanged and y is multiplied by 1/4. So we'll have y over 4. And I see one point that's really easy to do y over 4. It's this point 2, 4 or 3, 8. I'm going to take 3, 8 and bring it down to 2. 3, 2. Boop. There we go. That's the new function. And actually, it's just like been pushed down the road, hasn't it? It's still parallel with the other function. It's very cool. Okay, submit answer. Yes. Oh, look at that. Okay, no problem. This one, we're going to be multiplying all our y values by 1/2. So our transformation point, we just take this 8, bring it down to 4. Don't change the x value. And that's that. So that's stretches of functions. All right. Thanks very much, everyone. Good luck with your learning. Any questions, absolutely shoot me an email. Bye.